My name is Charles Leiserson. I'm Professor of Computer Science and Engineering in the Computer Science and Artificial Intelligence Laboratory at MIT. My group works on software performance engineering, which is making code run fast or otherwise use few computational resources.
Working with Charles is, I guess he has a much more broader view of performance engineering. He's much more in tune because he's had so much experience.
So I came to MIT 44 years ago. At the time, I was working on algorithms for hardware implementation. I designed a supercomputer, which in 1991 was the world's most powerful computer, the connection machine CM5. And I researched a lot of things having to do with parallel algorithms and parallelism. I eventually realized that the areas that I was interested in were all about one thing, which was essentially making code go fast. That has been the focus of my group for the last 15 years about.
We have weekly meetings, and where basically someone in the lab presents what they're working on. Everyone else in the lab gets to watch, they get to hear about what people are doing, and they get to pose questions or advice on which direction to go. And it's so cool because the lab is doing so many different things that's all related to this idea of high performance computing at one time. And so I think by going to these meetings and seeing what everyone else is working on, I get a ton of exposure to, wow, there's so much room in this space. There's so many directions I can take what I'm learning and apply it to so many different industries and so many different use cases at the same time.
Typical day is in a research thing is you work at the board, you work coding things up, etc. Nothing comes, and then suddenly one day you have an epiphany, and that generates the work that you need to do over the next several years. The students in particular tend to be my ace up the sleeve, if you will, for our work environment.
I've been working on a project with performance engineering for molecular dynamics. It's sort of just applying performance engineering to the context of molecular dynamics, finding ways to sort of speed up their simulations using our expertise in performance engineering.
My research project that I'm working on is making it easier for programmers to specify how they want any arbitrary data structure that they create to be processed in parallel. I think what's incredible about the CSAIL is just the absolute scale and the breadth of what's going on, right? Every time I get in the elevator at CSAIL, there's this massive poster board of all the different talks that are happening, and it's so interesting to see all the researchers at the top of their industries at the forefront of every single thing that they're working on, right? And it's I'm looking at these posters, and it's this thing that someone's talking about, that this professor is just casually giving a chat about in some room in the building, is going to be probably what, is the backbone of Google's new infrastructure. And they're attacking these problems and these very well understood problems in computer science with totally new paradigms. I think the creativity of the solution space in CSAIL is what really excites me, because I talk to my friends about how they're approaching a certain problem, and I'm like, it's creative, it's something I would have never even thought about. It's super cool, I love it.
So CSAIL is my ideal place to work. I love my colleagues and my students, both who are so bright and so motivated to make a positive impact on the future. It's one of the joys of being at MIT.